Chapter 9 Applications of Integration. Example 9.13. The question is evaluate integral 0 to pi by 2 root tan x plus root cot x dx. Integral 0 to pi by 2 root tan x plus root cot x dx. Solution. First take the given question as I. So I is equal to 0 to pi by 2 root tan x plus root cot x dx. This is equal to 0 to pi by 2. The root tan x can write root sin x by root cos x plus root cot x can write root cos x by root sin x. Close the bracket dx. Take the LCM. We get integral 0 to pi by 2. The LCM is root cos x into root sin x. So into root sin x. Therefore, this term is multiplied with root sin x. The numerator also multiplied with root sin x. So root sin x into root sin x, we get sin x plus here this denominator is multiplied with root cos x. The numerator becomes cos x because root cos x into root cos x, we get cos x. So close the bracket into dx. This is equal to 0 to pi by 2 sin x plus cos x. These two terms write in single root, root of cos x, root of sin x dx. Just multiplied root 2 in denominator and root 2 in numerator. The numerator term write in outside the integral. There is root 2 outside of integral. Here root 2 in denominator. In next line is a root 2, 0 to pi by 2 sin x plus cos x by this root 2, the 2 is introduced inside of the root. So we can write as root of sin x cos x and dx. Sin x plus cos x by root of 2 sin x cos x dx. Now consider the term. Let's take as the number 1 equation. Consider the term. Now consider, so 1 minus sin x minus cos x the whole square. First simplifying it, we get 1 minus, this is of the form a minus b the whole square equal to a square plus b square minus 2ab. So we get sin square x plus cos square x minus 2 sin x cos x. This is equal to 1 minus, we know that sin square plus cos square x value is 1. Therefore 1 minus 2 sin x cos x. Next 1, this minus is multiplied inside the bracket, we get 1 minus 1 plus 2 sin x cos x plus 1 minus 1 get cancelled, we get 2 sin x cos x. Therefore the term 2 sin x cos x is, this 2 sin x cos x is equal to the term 1 minus sin x minus cos x the whole square. Therefore, for that place 2 sin x cos x, we can substitute 1 minus sin x minus cos x the whole square. Therefore, our integral I becomes now, our I is equal to, the outside integral is root 2. So, write as it is 0 to pi by 2 sin x plus cos x by, for that term we can substitute this one, that is root of 1 minus sin x minus cos x the whole square into dx. Now we substitute for the term sin x minus cos x, u, that is u is equal to sin x minus cos x. Differentiating with respect to x, we get du by dx equal to differentiation of sin x is cos x, differentiation of cos x is minus sin x. Here one minus sign, it becomes plus sin x. Therefore, our du by dx is equal to cos x plus sin x. That is, du is equal to cos x plus sin x into dx. Now change the limits. The given limit is for the variable x. The 0 to pi by 2 as a limit of the variable x. Now convert this limit to the variable u. So form the table. It is x, here u, our x limit is 0 to pi by 2. Our u is equal to sin x minus cos x. So if x is equal to 0, our u is equal to sin 0 minus cos 0. It is 0 minus 1. So minus 1. So write here minus 1. And if x is equal to pi by 2, our u is equal to sin pi by 2 minus cos pi by 2. This is equal to sin 90 is a 1, cos 90 is a 0 is 1. Therefore, write here 1. Therefore, our integral I is equal to root 2. The integral is over, minus 1 to 1. For the term sin x plus cos x. For the term sin x plus cos x dx, we substitute the sin x plus cos x dx is equal to just du. So write du. So 1 root of 1 minus sin x minus cos x is a u. That is u square. Our dx. So for that place dx, so du by, so our integral I is equal to root 2 minus 1 to 1 du by root of 1 minus u square. Now apply the integral formula. This is equal to root 2. Our formula is sin inverse x by a. That is integral of the remembering formula, integral dx by 1 minus x square is equal to sin inverse x by a. Sin inverse here 1, sin inverse x by 1. Therefore, here our answer is sin inverse u. Sin inverse u. The limit is over minus 1 to 1. So one more time recall. So our I is equal to root 2 0 to pi by 2 sin x plus cos x dx. For that term sin x plus cos x dx, we substitute du. The denominator 1 minus sin x minus cos x. For that term, the bracket term value is u. Therefore, our integral becomes I equal to root 2 minus 1 to 1 du by root of 1 minus u square. Apply the integral formulae. So, by that formula, dx by root of 1 minus x square equal to sin inverse x by 1. So, in this place, we can write sin inverse u, the limit is over minus 1 to 1. Now, apply the upper limit and then the lower limit. So, root 2 sin inverse 1 minus sin inverse minus 1. This is equal to root 2. We know that sin inverse 1 is a pi by 2 minus sin inverse of minus 1 is a minus pi by 2. Close it. So root 2 pi by 2, it becomes plus pi by 2. This is equal to, so root 2 into 2 times pi by 2. This 2 get cancelled. Therefore, our simplified answer is pi root 2. So pi root 2. This is the answer for the integral I. This I is equal to pi into root 2. This is the answer for the given question 0 to pi by 2 integral root tan x plus cot x dx. Therefore, example number 9.13 over. Thank you.